Hello, everyone. Before I tell you about my research, I would like you to consider the following question. What fraction of all the substances that exist in our world, on this planet and out in the universe, do you think we understand on a fundamental level? The answer to that question is 5%. All of our knowledge in applied science, our technology, our medicine, are contained in these 5%. I'm a particle physicist. What I research are the fundamental building blocks that make up our world. We call these fundamental building blocks particles. We know what those particles are and how they interact with each other for the 5% that is well understood. My research aims to identify what particles the entire rest is made out of. In particular, we know that there are at least 2 mysterious substances that comprise the rest. In my research, I specifically investigate the larger of the mysterious substances, which we call dark energy. A very natural question that comes to mind is, how do I know that dark energy exists and how much of it is there? And to answer this, consider the following thought experiment. Imagine you're an astronomer and you have a favorite star in the sky. And let's assume you can measure how far this star is away from you. You write down your measurement and you come back at a later time, and again you measure the distance. But now you find that the star is further away than it was during your first measurement. This tells you that the universe is expanding. But that is not all. You come back at a later time again to measure the distance from you to the same star, and you find that it is even further away than what you had anticipated. Not only is the universe expanding, but it is expanding faster and faster. You can think about this as if both you and the star exist on the surface of a balloon that keeps expanding, making the difference between you and the star bigger and bigger. Dark energy is what we call the substance that is responsible for the ever faster expansion of the universe. Precisely the question my research aims to answer is, how can we figure out what particles fill up the balloon in this analogy? The cutting edge theory in my research field is that the main building block of dark energy is a similar one to the one that we also find in our visible sector, a so-called scalar field. This is because it has the unique property of not diluting as the balloon expands more. In a way, you can think of it as the boy only being able to blow blue scalar fields into the balloon. While this makes the scalar field a great candidate for comprising dark energy, unfortunately, it's impossible to directly measure it. We cannot look into the balloon, and the only observable effect in this theory is how fast the star is moving away from us. You may wonder, what about another type of particle, such as the yellow ball, for example, which I will refer from here on as light? It seems plausible that dark energy should have also such a building block, since it exists in our visible world. But remember that even if light existed in the balloon, since the boy is only able to blow in more blue scalar fields, after a while that would drown out the light and it would not lead to any observable consequences, even if it existed. What I have shown in my research from very first principles is that if a light particle exists inside of the balloon, then in a self-consistent theory, the scalar field will automatically multiply it through a process that is called thermal friction. This is meaningful because it makes it possible to have a balloon filled with light, even though the boy cannot blow it in this analogy. And the effect of that can be measured in 2 ways. The surface of the balloon will expand differently, which means that the star moves away from us differently. And moreover, it is possible for the dark energy light to communicate with the light in our visible world, which means that not only could we measure that effect directly, we can not only measure the expansion, but also that direct effectly. A big challenge in understanding dark energy lies in our inability to directly measure it, and my theoretical work opens up a promising avenue to change that. Thank you.